Okay, we're jumping into lesson 10.1. We are moving on to the next parent function we will work with, and that is exponential functions. Our first lesson is going to cover solving exponential equations using the method of finding common bases. So let's look at what the exponential function looks like. See the definition below. So y equals a times b to the x power is the form of the exponential function, where a is going to be any constant number, b is known as our base, which is going to be the value that's being raised to the exponent x. So the index number here, this power, is your exponent. So what we're going to do, when I ask you guys to find common bases, this is the value that I am asking you to focus on. This is the base, and common means make them the same. So we're going to do several examples by working through some of your delta math problems. So here in section 5.1, I'm going to go ahead and click and do 2 problems out of level 1 and 2 problems out of level 2 to help you understand how to solve equations using common bases. So I'm going to shift this up, and we're going to try level 1 first, and we're going to look at these problems. Now if you look on with me here, you were given a handout of powers of 2 all the way to powers of 9. And what I would like you to do is use this as a reference sheet as you seek out in making your bases common. So coming back here to our problem, 1024 to the x power equals 64 to the 2x minus 3 power. So our base is 1024 and 64. So what I want you to do is go to your power chart, and I want you to find the numbers 1024 and 64. As you look through those numbers, you will notice that you have a 64 here, but there's no 1024. So we keep on moving, and if you come to the powers of 4, you have a 64 right here and a 1024 right there. 64 can be rewritten as 4 to the 3rd, and 1024 is the equivalent to 4 to the 5th. So what we're going to do is rewrite those bases, 1024 and 64, based on what we just saw in our reference sheet. So let's do that. 1024 is 4 to the 5th, so I am going to rewrite 1024 as 4 to the 5th power. And then this x of your exponent, I'm just going to bring it down and tag it along. 64, the base, I'm going to rewrite it. 64 is 4 to the 3rd. 4 to the 3rd. Then I need to bring down my exponent. But my exponent is an entire expression, so I need to make sure and put parentheses around the expression because it's not a singular term like the previous x. Once you have common bases, so notice that this 4 is the same as this, you can use what's called the 1-to-1 property. 1-to-1 property, which allows us in essence to, what you like to say, cancel. So I can get rid of common bases, and I'm left with the exponent values, which I will bring down. Once I have brought the exponents and set them equal to each other, I will do my algebra to solve for the x. 3 times 2 is 6x. 3 times 3 is -9. I need to isolate my x. So I need to bring x's to one side. So what I'm going to do is I'm going to move the 6x over to the left-hand side by subtracting both sides. 6x minus 6x is 0. 5 minus 6 is -1x equals to -9. And now I'm going to divide by -1 on both sides, which results in x being 9. And this is my final answer. I will come over here, solve for x. That means 9 is my answer. I will hit enter and move on. So what I want you to do now, I want you to challenge yourself, and I want you to work this problem out. So I need you to pause the video, work this problem out, use your reference sheet, and then come back and check the answer, because I am going to have it finalized right in this spot that will soon be populated with written work. So pause the video now. Okay, welcome back. Check your answer. 6 equals x. Okay, if you have no questions, we will move on. So we move on to level 2. And we're going to look at problems that look a little bit more confusing, but I promise you it's the same process. So write this problem down as our next example, and let's see how to work these out. Okay, so here's our third example. So now we have fractions that are appearing in our bases. Okay, we have 1 over 2/16, and then we have 1 over 1,296. But right now what I want you to do is pretend that you can ignore the 1 for now, okay? And here's why. Because I want you to focus on just looking at your reference sheet for what's in this denominator. So 216 and 1296. Let's go to your reference sheet. So notice here in your reference sheet, we are looking for 216 and 1296. And again, it appears here in the powers of 6 table. 216 is 6 to the power of 3, and 1296 is 6 to the power of 4. So let's take that knowledge and go back and rewrite our problem. Okay, so here's our problem rewritten. So I took 216, rewrote it as 6 to the 3rd power, and 1296, I rewrote it as 6 to the 4th. Now here's a property that I want you guys to learn. If you have, so this is a side note, so let me change the color here. Let's go into this reddish one. If you have 1 over some number m raised to a power of n, you are able to rewrite this expression as m to the negative n power. So please do take a note of this property, okay? You will be learning a lot of different properties in this chapter, and here is one that's very useful to us in problems such as this. So using that property, let's rewrite 1 over 6 to the negative 3. So instead of 1 over 6 to the negative 3, we're going to rewrite it as 6, sorry, I said that wrong. Instead of 1 over 6 to the 3rd power, we're going to rewrite it as 6 to the negative 3 power. And then in parentheses, I need to put negative 4 minus 9. And 1 over 6 to the 4th power, I'm going to rewrite it as 6 to the negative 4 power. And in parentheses, put negative 2x minus 15. Okay? By the 1-to-1 property, I can cancel out my common bases. I'm going to bring down my exponents and solve these linear equations. Parentheses implies distribution, so negative 3 times negative 4x and negative 3 times negative 9 yields a 12x plus 27. A negative 4 times a negative 2x, And a negative 4 times negative 15 gives me positive 8x and a positive 60. Let us solve. I'm going to move my x's first to get them all on one side. So I am going to subtract 8x on both sides. That leaves a 4x plus a 27 equals a 60. I'm going to subtract 27 now on both sides. So combine 60 minus 27. That's going to be, let's see, 10 minus 7 is a 3, 5 minus 2 is a 3, and I'm going to divide by 4. So, although it feels uncomfortable that sometimes it can not end up having a fraction answer, a whole number answer, and you end up with a fraction answer, that is okay. So unless I made a silly mistake somewhere, our answer is x equals 33/4. So let's see if that worked out correctly. So 33 over 4, we will submit our answer, and lo and behold, we are correct. So ready to do your own problem. Let's move on and challenge yourself to do this one on your own. 1/9 to the 5x minus 3 equals 81 to the negative x plus 14. So again, pause the video, work this one out, and come back to check your answer. This is our last problem. Okay, welcome back. Check your answers. And here's hoping you got it right. If not, just look back at the work and see where your silly mistake is, because I'm sure that's all it is. And of course, if there are any other questions, don't hesitate to reach out. Thank you so much for watching.